First, turn the oven to around 375 degrees. To make a souffle, you will need a round souffle dish. The bottom is unglazed, which is thought to absorb heat faster because it is porous. The fluted exterior increases the surface area of the outside, meaning fast heat absorption. For this recipe, we used grated Parmesan, butter, flour, dry mustard, garlic powder, kosher salt, milk, eggs, sharp cheddar, and cream of tartar. Soufflés grow fast when they can grasp on the side of the vessel, so you need something they can hold. We added traction to the container by spreading butter around the inner surface, making sure to evenly coat the ground cheese. We tilted the container to make sure all surfaces were covered. We then placed the container in the freezer for 5 minutes to keep the butter cold. Keeping the butter cold increases the chance that the souffle will rise up. The next step is to prepare the roux. A roux is a paste of equal parts of flour and butter. To prepare the roux, we used 1 1/2 cups of milk, 3 tablespoons of flour, and 3 tablespoons of butter. We also assembled our other ingredients by grating 6 ounces of cheddar cheese, 1 teaspoon of dry mustard, half a teaspoon of garlic powder, and half a teaspoon of kosher salt. We melted butter over medium heat. Roux's purpose is to coat every flour granule with fat so then when hot liquid is introduced there is not any clumping. Because butter is 6 to 8% water, if we dump the roux in before water is cooked out, it will clump, so we waited till the butter stopped bubbling. We then whisked in the roux while cooking it over low heat for about 2 minutes. Then we added hot milk on high heat. Whey proteins won't gelatinize completely until they boil, and that will start faster with hot milk. Meanwhile, we separated the egg yolks from the egg whites and then beat the yolks until they were creamy and light yellow. This denatured the proteins and evenly distributed the fats, making them less likely to scramble once added to heated mixture. Egg proteins coagulate at around 140 degrees, and because the mixture is hotter than 140 degrees, you need to temper the eggs. We do this by taking a little bit of hot mixture and whisking briskly into the yolks. This slowly increases the heat of the yolks and prevents curdling, and the starch of the sauce is worked between the proteins, providing more insurance. Then we put this mixture back into the hot mixture while whisking constantly. We added the cheese mixture base in with no heat added. It is interesting to note that the base makes up less than 50% of the souffle, but 100% of flavor. Then we whisked the egg whites by combining 5 room temperature whites, 1 teaspoon of cream of tartar, and 1 teaspoon of water in a very clean bowl. Cream of tartar increases the acidity of the whites and keeps the proteins from binding to each other too tightly. Make sure there's no yolk in the mixture because the fat in the yolk denatures the foam. We also cannot mix the whites with a plastic utensil because fats and plastic share molecular structures and bond together. Plastic utensils often harbor enough fat molecules to crash whites. When the foam is frothy and has strong peaks that can stand on their own, stop mixing. If we had continued to mix, the proteins would have squeezed out their moisture and the peaks would have collapsed. The final step is folding the egg white mixture into the foam. It is very important that minimum stirring takes place as to not collapse the air bubbles. First, put 1/4 of the foam into the base and stir it in. This will help the base accept the rest of the foam. Now we are ready to fold. Divide the remaining mixture into thirds and then fold into the base. Our mixture is now complete. Pour it into the souffle bowl and note that if the recipe was completed correctly, it should come to about the top of the container. We then put the souffle dish into the oven and set the oven for 35 minutes. It is very important that you do not open the door because the reduction of heat will permanently deflate the foam. Voila! We now have our final product.